Hi everyone, my name's Caitlin Woods and I'm from the University of Western Australia and part of the NLP-TLP group. This conversation is about linked data and why I think linked data is to be the foundation of enterprise AI. Now, if you work in perhaps a large enterprise and someone comes to you and says, hey, what data products are you using in your business? You might say, oh, we're using some Azure products, we're using SAP, we're using some relational database systems, we're using Power BI for visualization, and that's about it. Well, in reality, this is what the data landscape looks like in 2024. So these machine learning, artificial intelligence, and data maps, they started being created in about 2021, and they've grown in size. They've almost doubled in size since 2021. And this data landscape is getting bigger and bigger and bigger. Now, I'm not expecting you to be able to read any of these icons, but there's some familiar ones there. There's Azure, there's Meta, there's all sorts of products. And big businesses are using many of these products. And what that means is that when you introduce a new person into your business, whether that be a graduate or whether that be a data architect that's been working in the field for many, many years, the chances that they're going to be able to understand your data landscape in your business is almost none. It's almost impossible, no matter how long that they're there, to really understand all the bits and pieces, flows of data that are happening in your business and all the different products that are used. Just to hone in on this problem, if you go and ask a software engineer or a data architect, hey, can you produce me a map of what our data looks like in this business? What you might get is some diagrams a lot like this. This is a diagram of a typical relational database system. And if you zoom in on one of the tables in this diagram, you might get a table such as BizNP, meaning business partner, that doesn't quite describe the data that it's capturing. And so really unraveling and understanding this data is a really time-consuming task. And often the ins and out of parts of this data are only known by one or two people in the business, which is a really big risk. At the same time, the world's moving to a space where fair data principles are expected. So fair data principles means that data should be findable, accessible, interoperable, and reusable. And this is particularly the case in domains that require to be open, such as government organizations. So we're at the same time as we're moving towards a world where no one understands the full data landscape, we're also moving towards where it's expected to be fair and follow these guidelines and principles. So what do we do? How do we manage all this? And this is where linked data comes in. So linked data, you might have heard referred to as ontology or semantic web, is a data modeling and data sharing paradigm that encourages fair data principles and also data interoperability and data reuse. So linked data uses open data standards such as the Resource Description Framework, RDF, or OWL, and formats data as triples. So linked data is a big field and is a really structured data sharing paradigm, but in essence, it's all about modeling concepts and their relationships between them. So entities or data points in your data set are also following this paradigm, assigned a globally unique IRI. So this is a web description that you see here. So for this domain, for this concept Tokyo, we see a web IRI that identifies that piece of data. And this has two benefits. The first benefit is that no other data set no matter what company they come from, no matter what part of your business it comes from, will ever have the same ID as you've assigned your piece of data. And it also means that these concepts are accessible via the web. So you can make this concept Tokyo accessible via a browser where you can provide documentation for that data. So linked data provides a mechanism to unambiguously define data concepts that you use in your business. Now, this is just one possible architecture for linked data in a business. And what you can see here is that data can come from various sources. You have data source 1, data source 2, and this data can be linked together to concepts in a semantic layer or an ontology and exposed as linked data via the web. So what linked data enables us to do is allow machines to talk about data in the same way that you do. So coming back to this BuzzNP business partner table, if you ask someone to define, hey, what does a business partner mean in your business? What you might get is, or what does a customer mean in your business, rather? What you might get is someone says, a customer is a record in this table where the status field is either 3, 4, or 7, meaning that they bought something and the last purchase time is not null. For us, that's not really how we would describe a customer. Instead, we would say a customer is a business partner who's bought a car from us. And using linked data, using concepts and the relationships between them, we can model data in the same way that we talk about it. Saying, for example, a customer is a type of business partner, a customer is a business partner who has bought a car, from us. Because this framework uses open data standards such as RDF and OWL, these really large community efforts, such as the industrial data ontology, to define concepts that we use all the time, that we use regularly. And what that means is that when we communicate within our business, when we across our business, these definitions are really clear and we communicate with other people working with data. So for example, someone in your business might say, when we say the word function, we're talking about the IDEO notion, and this is what it means. And someone else might say, great, that means we're talking about the same thing and we can combine our data sets. On top of these large community efforts to create what's called upper ontologies, we also have community efforts to create domain level implementations of linked data. So for example, our research group has been involved in developing a ontology or for failure modes and effects analysis, again, for maintenance activities and for procedure documentation using this linked data semantic web framework. Now, what this means is that if you need to model failure modes and effects analysis or procedures in your business, you can come and leverage some of these works without having to start reinventing the wheel yourself every time you have a new data project. And that can save quite a lot of money in your business. So I went to a platform here, Seek, where you can hire people and search how much does it cost to hire a data architect. And this is in Australian dollars. It said, oh, okay, we're ranging in $135,000 and $155,000 for a data architect. That's quite significant if they're redoing this work all the time. So what linked data enables us to do is really stop reinventing the wheel when it comes to defining data and modeling data. And there's lots of enterprises already doing this and already talking this language. One example is IKEA. So there's a very influential person called Katrina Carey, who's quite vocal in this space and has done several podcasts that are worth listening to. And what IKEA have done is used linked data to model their products. IKEA has some really unique problems and really unique challenges to solve when it comes to data because they're an international company. So, for example, what a bedroom means and what furniture goes in a bedroom in one country might be different to the furniture that goes in a bedroom in a different country. And that means the recommendations that they need to provide their customers on their e-commerce platform is different from country to country. And they need a way to capture this. And to do this, they've started using linked data for searching and recommending products to users or to customers. Another example is Able's material master data ontology. They presented at a conference in 2018 or 2019. And the problem that they had was when running Equinor's drilling platform, there were lots of parts that needed to be joined and matched with specific other parts. And we're talking thousands of fittings, thousands of flanges, thousands of pieces of piping, all with their own unique specifications and ways to define these specifications. So what they did, they built this material master data ontology using the linked data paradigm. And because they were able to model the concepts and the relationship between them and perform checks on those concepts, they were able to benefit from a cost reduction of 5% for bulk material orders, which in large projects amounts to more than 100 million euros. And because it was built using this framework, they're now able to reuse the work that they did for that project in multiple other projects. So we've talked a lot about linked data and how it helps us to understand our data and stop reinventing the wheel. But the title of this presentation is about linked data being the foundation of enterprise AI. So I think linked data is an essential ingredient in future enterprise AI, particularly where large language models are involved. And that's for 3 reasons. First is that linked data allows us to speak a common language. So for long-term AI success, humans and enterprise software systems and AI need to speak a common language so that when we say, for example, the word function, that we're all talking about the same thing. The second benefit of linked data is that it can be used to ground AI models. So there's a technique called retrieval augmented generation, and companies are looking into how to use linked data, how to use graphs to ground the knowledge produced by large language models such as ChatGPT in the data in your business. And a really good example is Microsoft GraphRag, and it's really worth looking into that if you're looking at using LLMs in your enterprise. And the final benefit that we haven't talked a lot about here is that because linked data enables us to model concepts and the relationships between them, we can also use it for data quality checking. There are some sophisticated reasoners that have been created that run across linked data and can be used to check for consistency and for correctness of the data. And sometimes large language models such as ChatGPT can be known to hallucinate. And so to be able to perform constraint checks and perform data quality checks on the information produced by an LLM could be really, really beneficial. And if you're working in an industrial organization and wondering where to next, where do I go next? How do I do this? How do I get linked data in my business? Some key groups to look at. And this is where I'm going to leave you today. Would definitely recommend checking out these groups and having a look at what they're doing, how they can help you. Thank you for listening.